And we are live. Yay! Hello, everybody, and welcome to Empiribox Science Week. Yes, we've got 5 days of exciting demonstrations and fun investigations that you can do in school or at home. Now, ladies and gentlemen, for those who have never met us before, this is Scientist Sarah, our social media scientist.
And this is Chris, our math scientist in-house at Empiribox, and he does all of the practical, fantastic science experiments that are on the website at empiribox.com.
Now, ladies and gentlemen, and boys and girls, we are going to focus on today's one, which is Whoosh, all the change. And we're going to focus on changes of state. Now, there are 3 learning objectives that we are going to cover. The first one is, can we group and compare materials based on whether they're a solid, a liquid, or a gas? The second one is we're going to look at changes in state, whether the substance is cooled or heated, and we're going to record the temperature in degrees Celsius using a thermometer. And the third one is we're going to focus on 2 important keywords. One is evaporation and the other one is condensation. Please don't forget that accompanying with the email and the link, you would have received a worksheet that's got a start activity, a step-by-step guide on how to do the investigation, and there's also a chance to look at skills and working scientifically. So if you want to plan an investigation, record and analyze some data, or evaluate your investigation as well. Now, before we get any further, we need to start with a little bit of a starter. And Sarah, jump in.
Okay, so I want you guys at school or at home to think about what you already know about solids, liquids, and gases, okay? I'm going to give you 30 seconds, which isn't a great deal of time, to think about how many things around you can you see which are solids. Okay, so solids are things where the particles are really, really close together. You can't squash it or squeeze it. It's got a very specific shape to it, okay? I'm going to set the timer, 30 seconds. See if you can come up with over 30 in that time. Are you ready? Go. Thinking about a shoe.
Oh, table.
Carpet.
Oh, you said shoe, didn't you? Chair.
Me.
Pencil.
Oh, bottle.
Oh, man, that's a good one. A glass.
You got 15 seconds left. A computer.
Fantastic, computer. Oh, what else do we have? My lunchbox.
A light bulb.
Ooh, a light bulb moment there.
5 seconds.
4,
3,
2, 1.
And stop. Well done, guys. If you manage to get over 30, you're already amazing scientists. Right, so now we want to have a think about what do we know about liquids then? So we said that solids are hard, we can't squash them. Liquids in comparison though, the particles are a little bit more free. They can move around, which means that you can pour a liquid, okay? It takes the shape of a container that you put it into. How many liquids can you think of? So you've got 30 seconds now. See if you can get up to 30 again. Are you ready? Go.
A liquid, that's a tough one.
Milk.
Oh, tea.
Water.
Coca-Cola.
Ketchup.
Oh, brown sauce.
Mayonnaise.
No, not mayonnaise.
I love mayonnaise. 15 seconds, halfway through.
Hopefully you've got some of yours ready there, guys, to see how many you can get. This is a tough one. What else could be liquid?
Bath water.
Oh, yes, definitely.
5, 4, 3, 2, 1. Fabulous, guys. I hope that you managed to get more than we did, which wasn't very many, actually, was it? We're supposed to be real scientists. Okay, so the next one's a really hard one. I want you to think about what you know about gases, okay? So gases, the particles can move around freely, completely independent of each other, and they fill the shape of anything that you put them in. There are a few gases that are easier to think about because we are breathing them in and out. Have a think about what you know about gases. If you can think of 5, I'll be really impressed. Are you ready? 30 seconds, go.
Well, you did mention something that we breathe out.
I did. What are we mostly breathing in?
That's a good one. Hopefully they'll get it.
I think they'll get it. They probably know more than us.
Yeah.
They've got 15 seconds left.
Hopefully they'll lead. I mean, gas. Oh,
do you think they thought about oxygen?
Hopefully, yes. And what do we breathe out? Carbon dioxide.
That's a good one. Gases are hard because you can't see most of them, can you?
True.
5, 4, 3, 2, 1. Fabulous. Well done, guys. If you manage to get 5, I'd be super, super impressed. Okay, so now we've had to think about our solids, liquids, and gases. Chris is going to show you a really exciting demonstration to show how we can take solids, liquids, and gases and change their state. Over to you.
Thank you very much. All right, boys and girls, ladies and gentlemen, all the wonderful people out there, we know that states of matter, there's 3 states of matter that we talked about, and we just mentioned solids, liquids, and gases. But did you guys know that there's actually a 4th state of matter? Yes, that one is called plasma. It's the same state of matter that we can find in our star called the sun. Now, we are going to focus on 3 of them, of course, solid, liquids, and gases. But I'm going to first of all show you something and how I can change a liquid into a gas. And for this, I'm going to use my trusty water bottle, you know, the water dispensing bottle that you've seen probably in your school or somewhere. And I'm going to use a liquid. And this liquid I'm going to use is called methylated spirits. Now, methylated spirits is a purple liquid, and I know it is a liquid because look, it takes the shape of the container and I can pour it. Now, I've got a very specific volume of methylated spirits in this little bottle, and I've got 50 milliliters of methylated spirits. Now, I'm going to take it, I'm going to empty all 50 milliliters of my liquid inside my water bottle, make sure all of it's in there. And then what I'm going to do is I'm going to use a process known as volatilization. So I'm going to make it more volatile, but basically I'm going to shake it. And if I'm going to shake it, I'm going to change that liquid into a gas. And this is what we're going to see here. So let's see if I had my Weetabix this morning. Yes.
Chris, give me some.
So at a nice angle, I'm going to quickly shake it. Oh,
you had at least 2 Weetabix this morning.
Oh, yes, I did. Turn it to its side, turn it around, and now I'm going to shake it a little bit more. Now, this shaking that I've done has caused the liquid to change into a gas, because I'm going to show you what happens. I'm going to now take all of the excess liquid I've got in there, and I'm going to pour it out in my beaker. So let's see if I can get all of that out there. All the liquid that I've got left over. Just a quick little one, just make sure all of them drips out. Almost there.
We're getting there.
Just the last few seconds. There we go, almost done. And here we go. Now, ladies and gentlemen, boys and girls, you probably noticed that I said to you a few times that I've put in 50 milliliters of methylated spirits. Now, if I were to leave my beaker onto the table and I make sure that I take an accurate reading, go down to eye level, I can see that I've only got 25 mils left over. So what happened to the other 25 mils? Well, that has actually changed into a gas. And the gas that I've got in here is trapped in there, but I'm going to show you that it is a gas because we're going to burn it.
This is where we're hoping we're not going to set off fire alarms or explode anything.
No. Now, Sarah's going to quickly switch off the lights. You can see a bit of a better viewpoint on this one.
Oh, guys, should we give them a countdown? Are you ready? 5, 4, 3, 2, 1, go, Chris!
All right, boys and girls, what did you notice? Yes, it's very loud. Did any of you see a nice flame coming up? A nice blue flame and then like all that orange? Yes. Which is also amazing that if you were to touch it and feel this bottle's actually warm. It's really warm. So it tells me that something's happened, a change has occurred. But you know what's the most beautiful thing that has happened? Remember that 25 milliliters that I had that was missing? I told you it changed into a gas. Well, because of the flame, that gas that was there got changed again, and it changed into water. And you guys can see that right there at the bottom, there's the missing 25 milliliters, but it's now changed into water. Amazing. So that's just to show you that I can use flame to change the state of something. By shaking it, I gave it energy, changed it from a liquid into a gas. Flame, I changed the gas into a liquid. How do you like that?
That's amazing. Where do our keywords come in?
Well, that's a great one. So as I was shaking it, the liquid, because I gave it energy, started to pop into all those particles, and it started to evaporate. Brilliant. And when it evaporated into a gas. When I introduced the flame, that gas has started to bond with what we've got outside. Remember, oxygen and carbon dioxide. And that's what changed it into water. So that's been condensed and changed into water. How do you like that?
That's amazing.
Fantastic. Now, the second demonstration, I'm going to show you something really amazing. I'm now going to take two different states of matter, one liquid and one solid, and I'm going to make a gas. Now, for this experiment, I'm going to use hydrogen peroxide, which is my liquid, and I'm going to use potassium iodide, which is going to be my solid. Now, potassium iodide is something that you can find potassium, you find in bananas. Hydrogen peroxide is the same thing that you can find at hairdressers, hopefully opening up on the 12th of April. Yay! And that's the same thing that we use to put on our hair to make it a little bit more blonder.
Not great.
No, definitely not great. No. But before we do that, ladies and gentlemen, what I need to do is quickly just prep it up, and I'm going to use a fairy liquid because I need to trap in the gas. So I put about a teaspoon's worth of fairy liquid inside my flat bottom conical flask, which is on my little cork ring inside my flattened bag. That's just so that it doesn't get messy.
It can get very messy. Very messy.
Now, it's also called elephant's toothpaste. Now, you might have seen it on YouTube and everywhere like that, but we're going to do a live version for you guys right here. Now, I'm going to use a little bit of my food dye because I want to make it look
Stripy.
stripy.
Stripy toothpaste.
Oh, yes. Oh, absolutely. Now, as I mentioned before, I'm going to use a liquid and a solid. So here's my liquid, hydrogen peroxide. I pour that in. All of that in.
Are we adding some green? Can we make it really stripy?
Oh, you can if you want to.
I have some green.
Yeah, by all means.
I'm going for it. I'm going to go some green down. Oh, there we go.
Fantastic. Now, ladies and gentlemen, boys and girls, you can see that there's a liquid in there because it takes the shape of the container. So I know and I can flow. It can flow. So we know it's a liquid. Next is my solid. And now, boys, again, we're going to focus on our observation skills. So look very carefully at what happens.
Oh, it's going. Woo-hoo!
Look at that.
Look, that's right.
Now, boys and girls, can you see the steam coming off? That's produced there is a gas. That gas there is actually oxygen. Yes, you would not believe me, but it is actually oxygen. I could test it if I can just quickly grab that splint. Thank you, Sarah.
There we go.
It's all right. Let's see if it works today. I've got my splint here. I'm just going to make sure my splint is nice there. Going to make glow, put it in, and look, it relights again. So I know that it's oxygen that's created in there. Oh, there we go. Now, boys and girls, what I was trying to show you here is how I can use a solid and a liquid to make a third state of matter, gas, and I trapped it in my fairy liquid.
Oh, we can still see it coming off, look.
Yeah, look at all those wonderful things. Now, that's the fun experiments that we've done there just to demonstrate it. But don't forget, boys and girls, ladies and gentlemen, you are now going to do your own experiment in your classroom or at home. Over to you, Sarah.
Okay, so this is the bit where you guys get to join in. So you, on your worksheet there, you have been provided with a few bits and bobs that you need to get ready so that you can have a go at an experiment for yourself. So you just need some plastic beakers. We also need, thank you, some salt. So this is the same kind of salt that you'd add on your fish and chips at home, that kind of thing. We could do with a spoon, just to give a little bit of stir and to add our salt in. Ice cubes also. And then we need just a beaker of water, okay? So what we're going to do is we're going to add some of the water into our beakers. So just about half full is fine. Into our beakers there. There we go. We're going to take our thermometer. Now you can, I've got a digital thermometer here, but you could also just use one of the normal thermometers that you kind of find at home, etc. So you're just going to turn your thermometer on, and then what I want you to do is to find out what temperature your water is in degrees Celsius, because we want to take some measurements here. Okay. Now you might find, to start off with, when you have your thermometer, it's quite warm in the room, and when you put your thermometer in your water, just leave it for a couple of minutes, the temperature might change because the water might be slightly different to the air temperature in your room. Okay, so we want to find a start temperature because we need to know where we're starting from, so we can work out if the temperature of the water has increased or decreased. Okay, so once we've got our start temperature, what we're going to do then is we're just going to add a teaspoon of our salt to the beaker of water and give it a stir. So once we've done that, we're then going to retake our thermometer and we're going to take some measurements. And this is up to you. So you want to decide if you're doing planning, how often are you going to take your measurements? You might want to do this every 30 seconds, every minute, every 2 minutes. That's up to you, okay? So we're looking at, has the temperature changed? Do you think the water is going to increase in temperature or decrease in temperature? What we're then going to do is we're going to carry on with the same experiment and we're going to add an ice cube to our beaker there. And once again, we're going to take the temperature. Do you think it will rise or do you think it will lower? And you can do this with different beakers, so adding different quantities of salt or maybe different amounts of ice that you add into your beakers. And again, you want to think about, are you going to do the planning for this experiment? So are you going to think about your independent variable? So what are you, as an independent scientist, going to change about your experiment? Are you going to change the salt, the water, the ice? What are you going to change? You've also got to think about, what's my dependent variable? What am I going to measure here? And how am I going to take those measurements, okay? You might want to think about your data. So how are you going to collect that data and how are you going to put it into a table? Are you going to just put it into a list there? Maybe you want to take some photos. That's completely up to you. Or maybe you'd like to evaluate your experiment. So do your experiment, do the practical and find out, actually, how could I have made this better? What could I have done to make sure that my results are as valid and reliable as possible? Okay, so don't forget that all of that information is on the worksheet that Chris spoke about earlier.
Yes.
Have a go at your worksheet and see how you get on.
Yes. And please, for our social media account,
send me some pictures and some videos, show me how you get on. Tell me what you find. I'd be really interested to know what your results are. Is it what you think it's going to be?
And ladies and gentlemen, this is our day one whoosh all change. We thank every single one of you for joining us today, and we do hope that you have seen some of the fun things that we can do with science.
What's our exciting experiment for tomorrow, Chris?
Oh, fantastic. Tomorrow, we are going to look at May the Force Be With You, rocket science. So we're going to make our own little rocket. Ladies and gentlemen, boys and girls, all the information will be on the email that you've received, as well as on the worksheet. So please have a look at it. And I do hope that you all can join us tomorrow. Don't forget, it's also International Women's Day today.
Yes, it is. Big shout out to all the ladies who are having a go at the investigation today.
And again, thank you to each and every one of you. As we mentioned before, ladies and gentlemen, this session will be recorded and that recording will be sent to you so you can watch it again.
There's loads more experiments available to you as well. If you want to check them out on empiribox.com, feel free to have a look and see what you can have a go at.
Yes.
Enjoy some science, guys.
Have a good day, guys. All the best.
Bye.
Bye. That was brilliant.
Yeah.
And stop the recording.